learning was a thing, we were building a 600 GPU multi-node cluster in the office, in the hedge fund, out of gaming machines. And so we were doing back testing on the GPU, and this is Fortune, yeah, it's the S&P 1500. So we were trading 40 stocks, long and short, changing every 5 minutes. And right around that time, is 2012, there was a lot of hype. We go through these hype stages. So you went through the big data hype, and then disappointment, and then predictive analytics, a little more excitement, but cautious excitement. There was a lot of hype around sentiment trading in hedge funds around 2012. It was really like baby steps for NLP. So as soon as NLP did anything useful and people applied it to hedge funds with price action sentiment, a lot of people got really excited because there was definitely some signal. And the funny thing is a lot of hedge funds failed. I would say I was part of one. Where now the technology has really come around. So using glue on NLP and deep learning, you can actually get more robust insights into language if you really wanted to trade on language. There's a lot more to trade on. I guess the other highlight there is we focused a lot on GPU memory efficiency. So we would take, a lot of times when we do deep learning, we just take what's handed to us. So whether you're using MXNet or TensorFlow, you just expect that they are using good practices on the GPU. At the hedge fund, we would spend an entire week porting very complicated code that really did not belong on a GPU, to a GPU. So like if-else statements, for loops, we would go through the whole process of porting it to the GPU. And so while I was there, we got to the point where our entire 5 gig, 5-year backtest would run completely in GPU memory without talking to the CPU at all. And that's all the way to like sharp ratios and everything, like the full 5-year backtest. That took a lot of work. We had consultants that flew in, and they would tell us that GPU memory was striped this way, so we had to like change all of our matrices over and go faster. So that was a good experience. I joined a Sequoia-backed startup called HireVue. Has anyone heard of HireVue? Most people, more people have. Half of the Fortune 100 use HireVue for interviewing. So I joined them, built out their data science team, and we started doing interview prediction. So 6 years ago, that was kind of a controversial thing that I don't know if AI should be used to predict interview outcomes. And now I think it's actually kind of used as best practices because HireVue has done a lot of stuff to do active adverse impact mitigation. So they can actually take racist or sexist training data, because that's where's that going to come from? It's going to come from the humans. And the AI will mimic whatever the training set is. And so HireVue has come up with ways where we've been able to block that bias we've been able to block the bias transfer from going into production. So the data science team there, they can train on a very racist training set and ship a model that is not racist within the US guidelines, and it still predicts performance. The last 2 years, I've been full-time with Ziff. We've got a few members here, got our CEO and head of sales, and that's been focusing on getting deep learning into production easier. And I'll go into more detail.
Oh, now it's on.
Can you hear back?
I can speak louder too. Is that okay?
Good. Okay. So I just have one slide. How many people here are trying to break into the data science space or get a job in data science? Okay. And I showed this at Data Science Go. So getting a job, we've hired data scientists, we've been data scientists, we've been on both sides of it. And the thing I kind of boiled down to is if you're really passionate and you're obsessed about the space, that's really encouraging, because most jobs that you apply for, no one is qualified really to be in that position a year from now, which means you're going to have intrinsic motivation to keep learning. So the next network, is going to come out a year from now, or the next, the next new algorithm is going to come out, and you need to be able to adapt quickly. And so, kind of a silly story behind that. We had a data scientist working on something for a week, and he had concluded that it was not a viable approach. He went to speech nets a couple years ago, deep speech 2. and our CTO asked if I would just take a pass on it. And I spent an hour or two, and I came up with some results that conflicted with what this data scientist came up with, and he had spent a lot more time. And the conclusion was not that I'm smarter than this individual. The conclusion was I have Googled a lot more than this individual. And so you don't really think of Googling as being a competency, but if you've been Googling for 5 to 10 years, you actually have an advantage compared to people that don't. I don't know what that sound is.
Somebody got shot. You can mute them.
Oh, you can. They're like mute all. I think they muted themselves. Oh, they muted themselves. Oh, sorry, everyone. Okay, you ready? So you put that on your resume. I am a principal level Googler. You Google really well. And that's just about like using quotes and ands and ors and knowing where to look. Do you look at Google Scholar? Do you look here? Do you specifically search on Stack Overflow? How do you find stuff? And so the other thing too, people always want kind of the secret sauce, what's going to get you a job immediately. And I've never seen anyone do this, but I think right now something that would really stand out would be to find out what internal stack a company's using. So if you really want to work at Ziff, or you want to work at Amazon or Apple, or some other company, understand what stack they're using internally, what technologies they care about, and become an expert in those technologies, and ideally become an open source contributor. So if you can actually contribute useful functions back into that framework that they start depending on. Imagine going into an interview and you say, hey, do you use pandas? And trying to say, yeah, of course we do. Are you familiar with this function? Of course we are. I wrote that function. I don't think that's maybe a practical interview scenario, but you could imagine what that would do for your interview outcome. Like, oh, well, we should probably hire you. Okay, so typical hello world. A lot of times when we start with deep learning, we're focused on a specific observation tied to an outcome. So MNIST is the classical hello world. I think the hope is eventually ImageNet will be the new hello world as the GPUs get faster and the algorithms get faster. That'll become more practical to solve. I think the latest, does anyone know what the latest benchmark is for the fastest time to solve ImageNet? It's like sub 30 minutes. I think that's on the cloud. There's a ranking. People are trying to show how fast they can solve the traditional ImageNet, which used to take weeks to solve. So one of the things we've learned interacting with the market the last couple of years is there's a huge disconnect between academic AI experts, which I'd kind of lump a lot of us into, and the business use case, or the business user. There's a huge divide there, and we didn't realize how big that divide was until we started kind of interacting with the market. And the first thing that kind of came up that surprised us, we were working with some damage data, car damage data, and an engineer. So we have images, and we're trying to predict whether or not there's damage in this photo. And an engineer was reviewing it. So this engineer is not an AI expert. And the engineer says, shouldn't you know that that car is a BMW and not a Honda Civic before you make your damage assessment? And kind of the naive AI researcher side would just say, oh, deep learning will figure that out. Like if that was useful, just give us more images. You give us 1 million, give us 10 million, we'll just magically figure it out. The problem is that image is an image of a wheel well. So even the AI, 1,000 years from now when we're gone, it still won't know that that was a BMW because there's not enough information in that viewpoint. So the thing we've had to adapt to is, on the business side, we have to include all the data that matters. And so this is an example we bring up this is our hello world. So this is a data set that we have. The goal of this data set is using all of the data items, you have to predict the price of this property. And there's tens of thousands of these properties. So can you train a deep net that will look at this property listing and give you a price? And for people that are familiar with machine learning, they realize there's a problem with this. There's lots of problems with this. The problems are you have hybrid data types. I've got images, I've got structured data, the size of the house, when it was built, how many acreage, I've got, what features does it have, number of beds, baths. And I also have a description. And then to make things even more complicated, I have different image types. So we know the features that should be learned from satellite data are different than the features that should be learned from Google Street View, and those are different from features that should be learned inside the house. So those images are not the same, and they should not be treated the same during the machine learning process. So we can take a data set like this, and we can put it through our platform, which right now we run MXNet in the background. We have kind of moved our understanding beyond a single image or video audio observation to an outcome to more of a flexible record format. So if an engineer or whoever's dealing with a problem, if they can represent the problem, and I'll just walk through this real quick. So I have, I've got a name, and a name would include something like whether or not it's, what's the foreign key? So what's the real estate property ID, or there's a foreign key in your system that you care about that means this is a unique record. And then the other thing is whether or not it's a holdout. So is this supposed to be used in training, or do you intentionally want to keep this away because you want to understand how well it'll do? And then in context, this is where we can throw in all sorts of data. We can throw in categorical, continuous, text. We can really throw in all the stuff that matters. And then the thing we've noticed with our files, I can have a single observation that might have 150 files. It's one observation. We have a group by name field in there where I can tell it that this is a satellite photo, this is a kitchen photo, this is Street View, and I can make sure that we respect that on the back end. So this data set is relatively small. We can solve this in, I don't have the latest numbers on it, but in a couple hours, if an engineer can construct the JSON, they can get a model finished with reporting and some feature insight, and they can deploy this. So this is exciting for us because we would have never come up with this a couple years ago, but interacting with businesses, this is kind of the feedback that we've gotten. And another fun example to bring up, really we see this as kind of level setting with the human, because one of the things that is never fair is what does the human know that the AI knows or doesn't know, and vice versa. So if you are trying to predict whether or not, let's say you're on a social network and someone's posting inappropriate photos or it's spam, a lot of times people would look at the image. Like, I'm going to look at one image and I'm going to decide if this is not safe for work. But the human, they know a lot more data than that. The human's going to look at how old is this profile, who are the followers, what are the comments, what's the image. This profile is definitely spam. And so since the human is kind of playing at that level, we want to make sure that we can allow the neural networks to play at that level. And then the last point on this, the way we see, so every model that we build is custom to the data set that we're seeing. And so the structured data is pretty obvious how you might featureize or tokenize that. But then for everything else, the text, image, audio, and video, we build the appropriate neural net connections, and then we pull it all together to make that prediction. So the nice thing is you get everything interacting together. So if there's signal in image, if there's signal in text, if there's signal in video. And the last thing, I apologize to jump around. We used to be intimidated by this problem, but we have other problems that are being solved on our platform that are even more complicated than this because they're using multiple videos. So it's not just one video to one outcome, it's variable video to an outcome. Okay, and I'll jump into the main talk. The last thing that I'll kind of wrap up on is the kind of where we see how we play in the AI landscape. So if anyone is doing an AI startup, the thing you'll always get asked will be, well, how are you different than everyone else? Because there's huge giants in this space, that are respectable giants. Well, how are you guys different? And so the way we see things is you can add more people. So you can just add, bottom left, you can add a lot more workers to look at images and do different things. That doesn't scale very well. Or you can have niche AI, so the top left. So niche AI is very easy to turn on, it's very focused. So imagine Salesforce with Einstein if you want lead scoring. If you're a Salesforce customer, congratulations, you can probably turn that on next week. Or if there's a specific API endpoint, I know a lot of the cloud providers, they have endpoints that are already trained, but are really good. You should just use them. Like, you shouldn't roll your own speech nets. I've done that. My co-founder and I, we've separately done that for different entities. It's a real pain in the ass. So if you can just hit an API endpoint, do that. The problem with these niche endpoints is they're very narrow. So they will do this one thing really well, but if your data is a little different than the data they were trained on, or if you need an additional like kind of tangent or side shoot, they can't support that typically. Down in the bottom right, you've got custom AI. So IBM Watson, Microsoft Professional Services, TensorFlow. If you want to roll your own, you can do that. The nice thing on this x-axis down here is business value. So the more you go to custom AI, hopefully you're not just wasting a lot of money on a science project. Hopefully you have this big effort to build a custom AI to ship value. But it's not easy to do. It takes a lot of time. And typically there's a lot of learning to be done because most people are not, and I'm not saying like everyone is not qualified to tackle this problem because it hasn't been tackled before, if you're doing a custom implementation. So we kind of see ourselves moving up into the right where we feel like we can do what feels like custom AI, that custom or that house pricing example, but we can do it very quickly. So if an engineer can construct a JSON record, we can build a model. So enough about Ziff. So the thing I want you guys to really appreciate is the power of neural net encodings, because a lot of times they're overlooked. So a lot of times we focus just on a model outcome. What is my accuracy on a classifier? What's my R value or F score on a regressor or something? And the thing that we're missing is with these encodings, they're kind of gold that are hidden in the neural net. So if I'm trying to explain neural nets to a less technical audience, I kind of explain it as a stack of pancakes, like a convolutional net. So I've got an image, I'm going to throw it on top or a spectrogram, and it's going to ooze through this stack of gross pancakes that have been sitting on the table for 4 hours. And that mixing is getting really complicated where we've kind of lost control of it. But down at the bottom, when we start flattening the net and we get that final encoding layer before we make the classification, that actually represents the features in the net that were the most meaningful, most important to make a final decision. So if I'm trying to predict the difference between a man and a woman, I might actually get something in there that's activating on a beard or increased hairline or something that's a little bit more telling. And so I like this example because it kind of shows that off. This is a model that we built where we're just predicting which country an individual's from looking at the face. So we know the source of the photo, and can we predict back where that source was from? I can train a classifier, so what? But if I take that classifier and if I expose the embedding layer or the encoding layer, I can then run t-SNE. This is just a t-SNE cluster. And what we've done is we've averaged those embedding layers by the country. And so this is the neural net's attempt to tell you where it thinks the countries belong based on the faces. Does that make sense? So just looking at faces, the neural network thinks, it's a little hard to see, it thinks that Chile is by Argentina. Is that right? Like, I don't know, that's pretty good. And you actually get these continent groupings. So Africa is grouped, and it's really interesting that the Caribbean is next to Africa because there's a lot of African ancestry in the Caribbean. And then you have Asia down here, the Middle East, in Europe. Does anyone know where this lady's from? I know there's a few people in the audience that know. Any guesses? Where would you guess this? Which country would you guess she's from?
Asia.
Asia. And no one has ever gotten the answer right. I'm so excited. So guess a specific country. I used to give Bitcoin away at talks. That actually ended up being really good for someone.
Indonesia.
Oh, okay.
It doesn't look like Asia. It's not Asia.
So she's from Greenland, which is interesting because
Greenland. You see?
so the neural net thinks that Greenland is an island. It's kind of out by itself, but Greenland it thinks is the most similar to Asia, which is actually true based on the ancestry. So people from Greenland were not. They didn't settle from the east like they did with Iceland, they settled from the west. And so the neural net found out what they found with DNA studies sampling blood a couple of years ago, just looking at faces. So this is a fun example of the power of these encoding layers with clustering and for topic discovery. This is another example. So if I cluster topics and then I apply some domain knowledge or business logic to that, I can find things that are really, really interesting. And so the red clusters and the blue clusters actually have real meaning for this use case. And so clustering is really interesting because a lot of data scientists and statistical people celebrate clustering. So if I just take ImageNet and I start clustering, I might show you things on an image data set or maybe a video data set that we will all be excited about. We'll say, oh look, we found all the bikes, or we found all the puppies, or maybe we found something else. But if it's not tied to a business use case, the non-technical people don't care at all. So the fact that we found puppies in your data set, there's like a blank, they don't care. As soon as you apply the business domain coloring or insight into these topics, they now are on the edge of their seat. They want to know, hey, we're losing all of our money in this region or this region. Can you tell us why? And so that's been kind of an insight we've learned in working with companies. You really have to bring it back to the domain expert and really the business value. Does that make sense? Like, because you can imagine clustering for clustering's sake, who cares? But if I show you a cluster where you're losing money, it's the most exciting thing that's happened this quarter. Like, you really want to know what's in there, what's going on, what's happening. The other thing we've been playing with, it's funny because people, so I'm changing the topic to GANs. Any guesses on which of these faces are real and which are fake?
E is fake.
E is fake. Okay. Any others that are fake?
They're all fake. E is fake.
They're all fake.
People who shop.
So these are all GANs. These are a little different. So we got a lot of attention 6 months ago. So for marketing, we're playing with genetic GANs. So these are old ones. These ones aren't as good. So these are genetically optimized to achieve certain goals. So these here are hitting a variety of models. There's a whole package of models that they're trying to maximize on race, gender, attractiveness, age, targets, things like that. These ones are funny because they're actually optimized on JPEG compression inefficiencies. And so these GANs are actually making a lot of hair because that doesn't compress very well. And so if you remember the old GANs, the new GANs are much better, but the old GANs, they look terrible. Like you had to cycle through 100 of them to finally get one that was kind of interesting. So with the genetic GANs, we don't have to get surprises like this. We can actually drive immediately to whatever our goals are. So if our goals are to get maximum face confidence or maximum attractiveness, which is really fun because a lot of jobs are on the chopping block. I know people are starting to talk about that, but that number keeps going up. I never thought professional models were on the chopping block this decade, but they actually are. So this isn't really, we allow engineers and domain experts to build custom models. Mass producing fake people for marketing agencies, that's not really our focus. This is a marketing piece, but we've had a lot of inbound interest where people are already interested in this because they have to pay tens of thousands of dollars for a human photo shoot. And if they can just, start producing a bunch of fake people so they can do hyper-persona targeting. So now instead of one ad campaign, you have 100 and these people are engineered to get you to click on them. So in the next couple of years, you'll be clicking on ads where people have purple eyes and you don't know why you're clicking on it. The other thing that we did that was kind of fun, a lot of times people think of GANs as, they're just producing fake images, but you can also go the other way. And so we built encoders, so I could take Keira Knightley, and this is actually with, this is earlier GAN technology where this would be much better. One of the motivations for doing this was we wanted to actually, we wanted to be able to take faces and actually do some crossbreeding. So if I have to give you a headshot, I'm going to give you a headshot with 5% Brad Pitt. Just enough for you to not notice, but maybe notice. Or the other fun thing that comes up from this, well, before I go into that, see how crazy this is? So this is a girlfriend bachelorette. We put her face into the encoder, and this is what the generator is producing. So it gets a lot of the core features right. You can see it looks pretty creepy. It looks like it's like an aftermath photo. I think now it'd actually be pretty good. So if you want to get your own GAN, which I want, I want my own GAN, that would we're essentially there now. I don't have a demo for you right now, but getting your own GAN, which brings up really weird copyright. So I don't know if you guys knew this. It's actually, so let's say I had a GAN that was Brad Pitt, and I can just start making all the Brad Pitts I want. I can make them smile. It's actually illegal for me to use that for my public marketing. And there have been cases where people have been sued, not for the GANs, but for like a voice singing imitator. So if I try to book you on my commercial, you say no. And if I get like someone to just come sing like you, I can get sued for that, and that's happened. So the thing that gets really weird is, what if I take Brad Pitt with this encoder GAN and I have him mate with a Ryan Gosling, and now I've got, this hybrid. It's like a 50-50, they kind of have the characteristics that I want. Who owns the copyright on that? So can I have Ryan Gosling endorse, or like a Brad Gosling endorse Ziff publicly?
What is GAN?
Oh, so sorry, a GAN is a generative adversarial network. So these faces, her face is made by a neural network. So the input is 512 or 1,000 floats, depending on how it's been designed, and it produces a face. So these faces are produced very, very quickly. They're genetically produced, so they take a little bit longer, but in less than a minute, these faces are made. They're not real people. And they're made to hit targets. So if you want a different ancestry, if you want a different age, if you want a different level of attractiveness, if you want them to be a smoker, that can just be requested.
So I know about GANs, but what did you mean by genetic GAN?
So we use a genetic algorithm to drive the latent space to produce GAN outputs that satisfy a whole bucket of model goals of pre-trained models. So we have models trained for age, ancestry, race.
So you have a genetic mutation algorithm.
Yeah, so it mutates the GAN to produce outcomes that are desirable, or to hit goals. So that's really fun because it gives you a lot of flexibility. I need to go a little bit faster because I want to get into the good stuff.
Sure.
So another fun one that we did that got a lot of attention. We actually did this as an ethics example because AI can be really, really bad. We've probably heard about some of it in the news. AI can do things that are terrible, and a lot of times it's not intentional. No one meant to do something terrible, but it just is. It's doing something terrible. So this is an example we built, and really this is a demonstration of what not to do. Like if you hired like this, I can guarantee this would be all over the news tomorrow. Or like if people find out, this would be a very bad thing to do. We built a neural network that would predict the rank of ABC's The Bachelor. So it's a dating show. So the neural network has looked at the last 8-9 seasons. It's looking at a new season, and it's deciding out of the 30 contestants where they rank. So that's the goal of the neural net. It's just trying to It's trying to rank people based on the face. And it actually did really well. So for season 22, the human picked this individual, which was the AI's third pick. And then the human changed his mind 2 weeks later and picked this person, which was a big deal. It was very controversial because the show's over. He changed his mind and went with the second pick. This was the AI's first pick. So the AI, before the show even started, just looking at faces, the AI said, well, you should pick her. And sure, you picked her by mistake. She was number 3. And we did this for The Bachelor and The Bachelorette, and both are predictive. The Bachelorette is more predictive. So we have proven that men are shallower statistically. It's now a fact. And if you're curious about the loss on this, it was hearts broken. That's what we were minimizing. We could have saved ABC a lot of money. So for anyone that's really serious for digging into video, there's different ways to think about video. So video, a lot of people play with video, they do frame level inference and training. So they're literally just firing on a video, maybe security, and they're looking for a face. That's one approach. This is a good, I would call this like the MNIST for video. If you want to tackle a temporal inference where the temporal data is really important for that prediction, it's not just frame level, you need a frame buffer. This is a really good data set, UCF 101, that you can use to dev on. There's pre-trained models you can play with, you can train on this, you can cut down a subset and play with it. I'm going to show you some stuff we're doing with the Ring video. So one of the interesting things, so this is really exciting actually. So we're moving into a new reality where pretty soon we're going to have more cameras, for good or bad, then we have people that can monitor those cameras. So right now we're limited by human queue. So if there's a shooting in an airport, there's a pretty long lag for people to realize what's going on, and based on who's reviewing the footage, it's going to take a while to figure that out. And so one of the things we were playing with is, can we take a very large data set of video that's a little overwhelming, and can we make sense of it? And so, so with Ring, we had 7 Ring cameras set up. Ring's nice, it all goes to S3, and there's really good Python APIs, so you can play with that data. And so something we did, so we actually did this piece right around Christmas. So the joke is like, can we have an AI that can tell if you're naughty or nice? This is that GitHub, by the way, for the Python Ring doorbell. This is not Ziff code, by the way. This is just a good API that we found. There's several out there. It had a lot of functionality. It was really easy to play with. So if you guys have a Ring camera and you want to play with it, pull down some video. These MP4s, they live on S3. They're minute-long clips. So this is a 4-year-old. This is my 4-year-old. He's really, really naughty. So he's actually making a huge mess right now in our kitchen. And this was something I was curious, like, can we find this? And ideally, can I have the phone tell me when this is happening so we can intervene? Because these will go on for like 30 minutes, and it's usually really, really bad, where it's, milk all over the floor and eggs, and we're trying to react to that. And here's an example of kids being good. So one of the concerns we had is we didn't want to build a model that hated kids. We didn't want to build a model that whenever a kid under 5 walked in the kitchen, it was like, get out of the kitchen. Because that'd be pretty easy to do. Like, you don't even need to build a model. You can just download like a kid, like an age predictor. So one of the fun things too that we're playing with, it's one thing to find topics in images. It's another thing to find topics in video and in audio, where you've got kind of this temporal review. And so the obvious thing is you can watch these rotating GIFs in a cluster to kind of understand what's found. Another thing we're playing with is, can I take a minute-long sequence and represent it as an image that a human, once they're trained, can just look at it and understand. So here we've applied color to time. So going from cold to hot, this actually tells me the temporal event. So this motion was triggered here, and it looks like the same individual walked over there and ended top right. This next one, these kids there's not a lot of color, which tells me they're just sitting around looking at an iPhone for a minute. So they're watching a movie on an iPhone. And I like this one. So this car pulls up, driver gets out, passenger gets out, dealing over here at the back, and then a kid ends up in the left. Does anyone know why the trees are white?
They're moving.
They're moving, but they have no temporal significance, which means they were always moving. So this tells me that it was windy. So it's fun, because when you start looking at this data, I could watch a mosaic of this that would maybe take 5 or 10 seconds in a sped up version. But once you understand what you're looking at, you just look at this, oh yeah, trees are windy and this. And yeah, just kind of, this was a fun kind of visualization. So getting back to indexing, I can index thousands of video events, and I can add kind of the metadata to that. So I've indexed these, and I'm looking at them on time of day. You can see the evening behavior is very different than the day behavior, but there's also clusters and pockets up here that are unique. And so I don't have examples right now showing you, but digging into those, you probably see like breakfast events, cooking French toast, stuff like that. There's some repeated behavior. Farther from the middle, the more unique it is, and then the tighter the cluster is, it also means it's more unique. You don't see it as much here, but sometimes we do get some garbage collection in the middle where it's kind of muddy. There's not a lot of value here. We have better examples that show that. And this just shows raw behavior. So this is just accounting coming off of S3. So I can see, this is my polyphasic sleeping. So I can see there's definitely something or someone active programming. And then morning routine starts. So I can see there's a lot of activity. And then in the evening, you can see there's a lot more activity, and then it tapers off, people going to bed.
So this is basically motion detection?
Yeah, this would be like motion detection. So Ring or Amazon, they're taking care of the motion capture, and then they they throw that in S3. One of the other things we're trying to tackle is there's false positives with motion capture on snow. We live in Utah. Bugs, they fly in front of the camera. Or cars driving past, like my garbage truck would set it off every Thursday. And so with AI, you can actually kind of put like a front row defense to make sure. Have you guys been in a coffee shop or something and you hear someone's ring notification go on? You hear that? Like, do you guys know the sound? It's really annoying. You know that? It's like I have it turned off, but ideally I would love it if my phone only went off when it was actionable, where it's, hey, we don't recognize this person. So learning people going into the house is actually pretty straightforward with deep learning. You can figure that out. This is kind of a darker side, but maybe an optimistic side. There's a death in our city where a 3-year-old girl was strangled by a blind cord. And apparently that happens. That's not like unheard of. Lots of kids die playing with blind cords. And so there's a lot of benefit kind of going to this approach, having a camera in every single room in your house. I know it sounds very big brother, but if that data is being processed on the edge, and if you have a loved one that is in need of help, wouldn't you want AI to give some assist, right? Or some notification. So I think that's a reality that we're all going to have, soon, where the likelihood of you having a kid, like my 4-year-old grabbing a knife from the kitchen and doing something stupid, will go down. Okay, Xbox. So here I'm actually going to walk through some code. So I've been obsessed about this for a couple years now. I didn't think this was possible in 2019, but I was. I would love to be able to beat a 7-year-old on the Xbox because I physically can't. My ability to, my reflexes, I just can't do it. So I'd love to have a GPU do it for me. And so you've probably seen like the DeepMind, the Atari games. So this is where people started. They started playing all these old games. The graphics are really simple. The inputs are really small. The short-term objectives are clear. It's funny because when DeepMind was building these games back in 2014 or when they started, it was revolutionary. People couldn't believe what they're doing. But now this is considered very toy. So anyone in the room could go download code and not just download it, but understand with some limited reading exactly what is happening and why it's working. This is considered a trivial MNIST problem now. And then you had VizDoom. So they were able to train a model to go play Doom. And this model it's doing lots of things. It's picking up health kits, it's shooting monsters, it's avoiding getting, so this is all autonomous play. You guys play Doom? Yeah, amazing. So we kind of laugh when we see the game now because it seems so simple, but this model was able to train just with random gameplay initially. I think some people split up into two, where they had navigation, and then they had, first it figured out navigation, picking up health kits, and then it figured out shooting, and then it was able to just self-play. The thing with this is this can play a million games because it just simulates them very quickly locally, and it can learn that way. But it's pretty cool because if you really watch it and see what it's doing, there's a lot of perfection that's happening. So if it shoots, there are a few examples where it shoots a monster and the shotgun kicks up, and the moment the shotgun's ready, it shoots the next monster at the perfect time. So it's really good at optimizing. And then Dota 2 was a big deal with Google. Playing Dota 2, they beat 5-on-5, so it's hive mind. People weren't freaked out yet, but maybe they should start to be. And then you guys hear about Starcraft? So Starcraft, there's a lot going on here. So you can see, looking at this, they have models to predict where the players are, who are what are the types, what's the health. There's a lot of different models. This isn't just one model that's doing everything. They have to build all these different models. And this was able to beat, I haven't heard any recent updates, but it was able to beat one of the best humans with Starcraft to date. Maybe they haven't exhausted that, but a competitive human was beaten with this approach. The other thing too is it kind of gets back to is this fair? And so one of the issues they ran into initially is the computer was allowed to look at too much of the map. So something that was actually physically impossible for a human to do. And then the other thing they ran into, the computer was allowed to do too many actions. So the human can, I guess these professional gamers do a ridiculous amount of actions, and so the human wasn't able to do enough actions. And so they tried to level set. They tried to make it fair. Someone was telling me that with more analysis, really the computer's winning on like the micro battles, because the computer's kind of doing this micro control where it's moving people that, like individuals that have bad health are being rotated out and coming in. So the computer's really good at that. But I want the computer to play this. And so this is 1080p, it's a 3D environment. There's a lot going on here. There's not a full game engine. You can't just like simulate locally. You actually have to learn based on online play. And so the issue here was, how on earth do you get this onto a GPU system? Like how can I make you play yourself? Because I've got this third-party Microsoft device. I could get in there and start like try to install Ubuntu system, but I didn't want to do that. I wanted to have a vanilla Xbox that just plays itself. And thankfully, other people have kind of figured out the elements. And so there's this group in France. You can build this yourself, or you can just order this part from them. It's $30. So this USB part will do a man-in-the-middle attack and trick the Xbox into thinking your Linux GPU machine is a USB controller, and you can play through it, and you can control the Xbox. And then you can capture with USB 3 capture card. So all of this, less than $100, and you have what you need to get the data from the Xbox. Linux has this Video for Linux utility driver. I can look and see that this HDMI input is essentially seen as a webcam. So it is seeing the Xbox just like you would with any other webcam. How many people have done webcam inference? You played with it? Yeah. It's not bad. It's not bad. There's example code out there. You can use MXNet and start doing live video inference on a webcam. So now I can see this. So if you've used subprocess in Python, it's actually really powerful. You can come up with some pretty complicated commands. There's an FFMPEG Python library out there. I would actually discourage you to not use it, because anytime you're adding new dependencies into your system, it's just a problem, and I don't think it's really justified if you understand how to use FFmpeg. So FFmpeg it's a great Swiss Army knife. It can do all sorts of things that, just like OpenCV. Like OpenCV is really, really powerful. It's more powerful than most people realize. FFmpeg's great. So if I'm reading from the local video, I can tell it where to grab it. I want it to come at raw video, and I can resize it, and then I can have it, normally you have it go out to a file. If I wanted to just record to a file, I can have it go out in raw RGB24 directly into Python. And so, so this is the final command that I'm using, and I can declare the frame rate. So I was able to run 60 frames per second, but then my capture card would crash. It wasn't robust. 30 frames per second I could run for hours. And I produce it's like half a terabyte of data I think it's a full terabyte of data per hour. So just playing, you're making a terabyte that you're transferring through the wire. So this command, you can drop it into subprocess. Oh, and this is one way to check. So if you're wondering like, hey, am I getting the right feed? You're looking for a binary feed coming off the webcam. So here I'm just using vanilla subprocess. I have to tell it how big the buffer byte size is, but it's actually pretty straightforward. It's just the size of the image, so it's X, Y of the image, its color, so it's 3, and then the frames in the buffer. So how many frames do I want to sit in memory? Do I want 1 frame in memory? Do I want 5 frames? So this is how you're going to be grabbing frames out of memory. And I just run that into subprocess and create a pipe, and then from that pipe, I can just have this while loop. So all this while loop is doing is it's hitting the pipe for the standard out, and it's grabbing those frames, and then they go right into NumPy. And not only that, I convert it into the right tensor format. So this is right out of the camera. This is firing. It's a tensor. Since I'm pulling out more than 1 frame, I have a batch. So I can pull out batches of frames and blast those through a GPU, and I can actually go really, really fast. I'll show you some benchmarks. So that's pretty straightforward for you to get a tensor object off of video onto a GPU. Like, I'm not throwing it on the GPU right now in this code, but once you have a tensor NumPy array, anyone that's done anything with MXNet would know, oh, I know what to do with that. That's pretty easy to make a prediction. So MXNet will throw that, it'll convert it to an MXD array, and you can throw that on the GPU. And you can actually throw it onto multi-GPU. You can split this batch, you can have it go to as many GPUs as you have. So this kind of shows the human inefficiency. Does anyone play any of these games? Yeah, a few people. So as the human, I'm playing this game, and really I'm going to show you some examples to just point out the human inability. Like, I'm trying to convince you that humans are already going to lose this game. And so the reason they're going to lose this game is I see someone, I need to manually bring the gun up and try to shoot them. And this is me trying and failing to do that, because this is all happening in like 1/10 of a second, and it's very stressful. And this is them killing me. And so I kind of had the heads up on them, they're killing me. But the interesting thing that I didn't really realize until I got this data kind of coming through the pipe is how much stuff is going on. So to do really well, I actually need a third eye, because there's a lot going on. Like, there's the stuff in the corner I could be looking at, but it's actually worse than that. Because to really do well, I need spider eyes. Because this tells me how many bullets I have left, this tells me my health, this tells me the enemy's health, that tells me the full 360 radar map, so I know if they're around me. There's all this stuff going on. So I need to know all of that. Or I need to know all that, but for me as a human, it's impossible, because humans are very bad at multitasking, which is why AI is so good. Let's see. And then there's a lot of information coming off. So here's actually a reward where AI is being thrown back saying, oh, congratulations, I'm going to give you a score. So you can see already this is kind of an overwhelming problem. Like, it's one thing to get the data, it's another thing to manage it. So just pulling a terabyte off of the Xbox every hour, I don't have enough humans that I can pay to go through at 30 frames per second and start labeling all that data. And that's why the indexing is important. So here's a region where I got killed. And how do I find these regions? How do I find these regions automatically using deep learning so I can start applying metadata? Here's a quick benchmark. So one of the things I didn't really hit on, a variable you have here are how many frames do you allow to sit in your memory buffer? How many frames do you grab out of the memory buffer? So do I do 1? Do I do 2? Do I do 200, 400, 600? So you can see I can actually run faster than the frames can be supplied. So 120 frames, I have no issue pulling 120 frames through if they're available. And so keeping up with 30 frames per second in real time is not a big deal at all. But you can also see I have no returns going past that. So and the other thing too, this is not multi-processed. So when I am pulling the frames in, I am pulling them on one thread. With everything else we do multi-threaded polling when we're actually running on like a real. This is running on a live feed, but if we're running on a video frame, we do multi-processing. So you would get even better throughput. And I don't remember the numbers off the top of my head, but it's insanely fast. If you switch to multi-threaded, you're definitely going to exceed everything that the captured card offers. I think you hit like 1,000 frames per second or something. So with encoding, I can take a 1.2 gig file, and my index is actually 7 gigs on disk. So it's kind of interesting, because a lot of times you think about encoding, you're going to make things smaller, but depending on the length of your encoding layer, with the video I'm dealing with int 8, but on the encoding I'm dealing with floats, and a lot of times it's float 32. So it's interesting that I can take a video file and produce a massive object that is kind of overwhelming. And so this is just showing some of that assist where I'm taking a bunch of this video data and I'm able to organize it into these groups to do some review. I don't have a good mosaic up here to show you what we're finding, but this is a way for you to kind of organize some of this stuff. And I'll show you.
So this is just showing you, this is normal gameplay. This is looking at some optical flow, and then this just shows you some enhanced. I wanted to throw up some actual grad cam where you could see like enemy activation, but I think the exciting thing here is this running in the wild in 2019 is like it's definitely doable. The problem is this will be incredibly hard to stop. So when we talk about disrupting the human modeling market, what is this going to do for the poor 7-year-old kids that like to play games online? Some of these games, like this will be, you could have people out there with AI just kind of dominating this space, and Microsoft or companies that have this would have an almost impossible time to monitor it because it's not happening at the packet level. It's happening past the Xbox. It's happening on the user side. I'll wrap up. So with that magical USB from France, which you can go build yourself, I actually get all of this data just streaming into MXNet. So I have all of these controllers. They all have values, and the values actually tell you a lot. So A is a number from 0, so the actual A button is 0 to 255. The RT button, which is the shoot button, is variable. So, like, I didn't know that. I thought it was shoot yes or no, but there's the controller is sensitive enough there's a variable pressure it's reacting to. This shows you movement. The separation here, 1, 2, 3, there's actually 3 different games. So it means there was intense play, and then the controller was put down, and then there was intense play. And then this shows you shooting. So if I want to find all of the active fight sequences, they're really easy to find. I can actually just use the controller output to collapse all that video data, and then I can just train on really compressed fight sequences. So this shows you the 3 different games. It's kind of amazing how much data you generate. You don't really realize it. So like a terabyte of data per hour plus the complexity of all of these control time series, it's all just, you take it for granted, but you can feed it right into a GPU machine. And this is the second to last slide, and then we'll go to Q&A. So the real reason I was excited, and this is just, all of this is just a passion project. So this is just, this month, can I get the hardware? Next month, can I, kind of limp this along? The real exciting thing that I don't think people realize is, so I think with some of the stuff I showed you, I kind of hinted that the human side of this is already lost. Part of that is multitasking and accuracy. AI is incredibly good at short-term reward. So once you really nail down the short-term reward, what that is, it'll be really hard for you to compete. But the place that things get kind of overwhelming, where a lay audience would not understand this, is I can actually have multiple Xbox entities on one machine and one model. So when I'm feeding frames in, I don't have to feed in 1 frame set. I can feed in 3 frame sets or 5 frame sets from active entities where the single model consumes all video input, but it controls all players. So it's a hive mind, kind of like Dota 2, where humans get confused by this. So if you had robots that came in the room, if there were 5 of them, you might think you're fighting one. You're fighting all 5 at the same time. They see everything they see, they control everything they control. So this is kind of a scary thing, because I think in the next couple of years, you'll be able to demonstrate something online where you could physically go into a world and attempt to interact with a hive mind, like on a military side. And I think the scary thing for us is if you see that, you might realize, like someone might realize, how do I get this into Boston Dynamics? Like, we were sending the best military strategy teams into this city environment, and this hive mind is always killing them. How do we get this automated? So that's kind of the concern with, long-term, human extinction. But I think as far as, the AI side is pretty fascinating. Does that make sense? 3 video frame buffers could come into 1 net, or multiple, and you could actually control all players. So I want to open up to questions. Okay, so that's right at the hour. Any questions that people have around? Oh, you probably can't see up here, but I got a few TensorFlow stickers on my laptop. I don't like TensorFlow. Actually, I I really hate TensorFlow. I've used it several times. I really like MXNet. We've tried all the different frameworks. The thing I love about MXNet is if you're doing multi-GPU, it's literally a list. It's a Python list declaration. If you've done it in TensorFlow, you have the session object. We've had major issues with version. You actually can't do a pip install. As of last week, you could not do a pip install for TensorFlow for CUDA 10. MXNet has had that available like from day 0, essentially. So, any questions?
What do you think is a cool weekend project for Ring?
Oh, for Ring? I think building a model to detect, so you can get facial recognition, which is just kind of an optimized embedding. So doing facial recognition where you have a database lookup, where it kind of figures out who's coming and going. And so building a model with Ring where you could just detect if it's a new face, I think that could definitely be done in a weekend. It's a fun project. Or identifying individuals in a household. And then you would know your own system. You might notice there's certain false positives like garbage truck or moth. You want that to go over. That would definitely be a good weekend project. But Ring's a lot of fun because it's your house. You can set it up how you want. The Python APIs are fantastic. And it's all on S3. It means it's really easy to play with.
So you mentioned that labeling is hard when you were grabbing these videos, right? So you referred that you use indexing, partially labeled videos.
Yeah, so we have pre-training coders that we use to find topics and to organize data sets. That's the other thing I didn't mention. Dealing with data in the real world, the data is terrible. Like it's always terrible, labeled or not. So some people have no labels. They have mass amounts of video. Hey, here's 10,000 hours of video. Tell me what, like find something in there. So in those scenarios, we run pre-training coders to do organization. And the nice thing we found with those is we can still get pretty good topic discovery, even if it's not something we've necessarily seen before, just based on the feature soup.
And you run it as a batch job, or like do you do this like a batch?
Yeah. So the way that, we run that as batch inference through video files. But then when we do the indexing, the nice thing with AI-assisted labeling is today the standard is 1 at a time. It's literally, look at an image. It's worse than 1 at a time because you're going to pay 3 best, 2 out of 3, best 4 out of 5, or whatever, 3 out of 5. We're going to pay 5 people to go look at an image and decide what this is. The nice thing with AI-assisted labeling is you can have a domain expert look at a cluster. And so a lot of the times we look at the topic or a cluster, they're pretty clean. Like, hey, here is, here's a triathlon, or here's this. And so the human expert, instead of labeling one object, they can do bulk labeling. So they're labeling the whole cluster. So whether that cluster is 1 or 1,000, it allows them to move very quickly. The other nice thing we see with AI-assisted labeling is if you rank your data sets, it's an easy way for you to find mislabeled data. We have a data set that's not safe for work. And so when we train those models and classifiers, if we rank the entire data set on where were we 99% confident that this was not safe for work, and the label is, it's the opposite. And when we do that, when we look at the polar extremes, we typically find mislabeling. And sometimes that mislabeling, even for people that think they have the best data, we've done a lot with Google Street View. We found some really weird things in Google Street View where we're thinking, how did that get in Google Street View? And it just shows up with the indexing.
Regarding the same thing, so when you have the data, so how do you test that, the results? What do you test all those results again? How would you measure the accuracy? For these assisted labels that you produced, because then the test, the thing that you are comparing against is also human labeled, right? And the answers that we have that we're comparing our results to are again might be wrong.
Yeah. So I think it's good when you're looking. It can be very telling when there's a big disagreement between the AI and a human. So let's say I get a data set that's labeled, or it's had some AI assist, we think where it's good enough. It's typically good to start. You train a model, you get something going, and and then where the model has the biggest disagreement with the human, that's the way, because normally to get a data set really good, there's always going to be some type of a process. The worst scenario is that process has no assist. Like if it truly is like, well, we're going to look at stuff randomly. So anytime you have an AI assist, then that can be an efficient way to start. You're looking at the biggest delta. Like you look at your probabilities and your labels, where you have the biggest gap. That's a good place for a human to review what the AI did.
Do you have a way to find out like fake videos or fake images?
So one of the issues with that, the GANs that we show, they're actually trained to create AI that makes it more difficult to detect. So the answer is yes. So today, yes. Today you can train an AI to find fake videos, fake photos, or fraud. But the problem is, if I train an AI to find fake photos, I immediately can start producing fake photos that are better based on that insight. So, like if I train a model to find fraud on social media, and if I know what features are driving fraud, then I can improve my fake generator. So I think it's kind of a losing battle. So maybe today it'll be hard, but 5 years from now, I think that would be almost impossible to detect a fake face or maybe even a fake video. Or voice authentication is kind of already killed thanks to AI. Like my voice is my password from sneakers. That you can fake anyone's voice just by getting a recording, and deep learning can generate new words said that they haven't said before. Yeah, so it's kind of a losing battle.
How much? What's the length of recording you need or video you need to generate the fake?
I haven't looked at the latest research, but and we dealt with this too at HireVue. We did some voice authentication with Siamese nets, but the interesting thing is if you have a fraud detector internally, you can dev against it, you can test against it, you can get things to pass. So if you have a model that does voice authentication, you can use some of these newer techniques on voice matching. So I don't know, I have an answer for you, but I think it's like it's less than 10 minutes, something like that. But maybe I'm wrong.
So you mentioned what you like about MXNet. How about what you'd like to see in terms of an enhancement, or what you don't like?
Yeah. So MXNet, we've had really good performance through it. We've been really happy to have multi-GPU. A lot of things that people take for granted, maybe in something like Keras, you have to write some more of it yourself. I think that's improved a lot. So with Gluon, they have a Gluon front end that's really nice. It has some new properties that weren't there before, which make it a lot easier. Some of the loss reporting, when you're training a model, sometimes you have lots of losses you're tracking. It's not just one. Because on our back end, the thing I didn't mention, so with that JSON record we showed, you can have lots of context items. Those contexts have a target flag. So I can actually have one JSON record that predicts 13 things, regressors and classifiers. So when we train on our back end, we have to track all of these different losses separately for reporting. And that's been kind of a hassle process. Our use case is weird though. But some of the loss reporting can be kind of a hassle. But the thing we've talked about internally, a lot of these machine learning frameworks are hard. Like they're not written by traditional CS graduates, and they're not necessarily all intuitive. But relative to each other, we definitely prefer MXNet. I used to like Theano a lot, which I think that's been discontinued. But MXNet came out pretty strong from the beginning with really good performance numbers. I think PyTorch finally caught up to it, but we like MXNet right now.
When you're training a model based off of video frames, is there any benefit to using delta frames rather than the actual frame?
Yes, there's lots of different ways to do that, and we do some of that on our end. So with the UCF 101 dataset, I think the best benchmark out there, they actually use, they enrich with optical flow, and then I think they train on both. They have optical flow and traditional. On our side, we do look at some of the temporal differences on short horizons. But yeah, video is interesting because you can get a lot of value from frame level, but as soon as you have a temporal problem where you know temporal is important, then there's different ways you can play with that.
So, like, do you, when you do this training, do you do it like on one machine or multi-machine, or is it like one machine with multiple GPUs? Like, what has been your typical use case?
So we started on one machine, and now we've got Kubernetes where we can train on multiple machines. So, but there's some big machines out there. Like, if you have to choose, I would just vote. Like, if you have access to a big machine, I know Amazon's got like these 16 GPU monsters. So if you can train on that rather than multiple, that would be ideal. And then, yeah, I know they have 16 GPUs. Like, if you want to go buy one, you can. But they have some 10 GPU motherboards out there too. So.
Hi, I'm on the phone. Before you were saying when training stock images, you can choose attractiveness of the people you're generating.
Yeah.
How do you train a model for something that is subjective to attractiveness?
So I personally hand labeled all of them. I'm just kidding. So attractiveness is fun because it's kind of crunchy ethically. It's like, well, how would you do that, or how could you? So ours has been trained on peer-reviewed data based on the region that was publicly available. The interesting thing with attractiveness, so getting to models, learning things that are unexpected. So our first attractiveness model, we had 1 million celebrity photos, 13,000 unique celebrities that are not included in that training set. So we trained an attractiveness model, and then we ranked these 13,000 celebrities, and the number one pick for the women was the lingerie model. And so it turned out that the net had learned to reward sexualized beauty based on the social data that it had access to. And so we corrected that with a face crop. The face crop was just very much focused on a type face crop. And then the second model, the number one pick out of 13,000 celebrities that we've never, they haven't been seen before, won Miss World. So like, what are the chances that I reach my hand into 13,000 paper slips and pull out a Miss World? Well, it's probably 3 or 4. So we're pretty encouraged. But the interesting thing is we noticed our top 10 rank, it had a lot of Indians, which is, maybe that's right, maybe that's not right. So we looked at racial distributions, and we saw there were definitely some differences in racial distributions, and where Indians were skewed high. And so we changed the attractiveness ratings to be a percentile of the perceived race. Because it's okay if people are skewed high, but you don't want a race skewed low. And so the new attractiveness metric that we have has no racial differences because it's trained on the percentile. And we were showing it to this group, and someone said, you shouldn't have done that. And I was like, what do you mean I shouldn't have done that? Because like, there's no way I'm going to allow a racial group to have a low skew. And they said, well, you shouldn't have skewed the Indian race down. I said, why? And they said, well, India apparently has won the most Miss World competitions out of any country. They've won 6. And so attractiveness is just messy. It's like, and the funny thing is attractiveness comes down to beauty's in the eye of the beholder. So in regards to AI, that it's different, because if you want to know what I think is attractive, you really have to run thousands of photos through me and train an AI. If you want AI to tell you what attractiveness is for LA, AI actually knows better than you do, because AI is able to kind of sample. So it does come down to who's the audience, who are the peers, and that could change. So it's interesting because there's a lot of terrible things in human data. So HireVue, they've kind of had to deal with some backlash just from people reacting to, I don't want to have AI reacting to my interview. I don't want to have AI having an opinion whether or not I should get a job. And the interesting thing is, as soon as you start surfacing up the human data, you realize that, oh man, humans are terrible with their process. And so we did a study where we showed that attractiveness had an even higher correlation to selectivity than race and gender combinations. So typically that's always talked about is race and gender underrepresented minorities are negatively impacted in the job market, and they are. Like that's a fact. There's science, like there's statistics there. But attractiveness has an even bigger discrepancy, which is super sad. So we have data that show that for men and for women, that is a bigger contributor to your selection. There's the humans for you.
Can you rephrase that? Like, can you
So men and women that are top quantile for attractiveness versus men and women that are not, there's a significant difference in their first impression. So whether or not they get a job. So it's not something that people really talk about. I guess IO psychologists knew about it, but now that we've got data to show that, it's like, oh, well that sucks. But the nice thing is with AI can be made blind to that. So this is a study that we did, and then HireVue did a separate study where they showed that there was no beauty bias with any of their algorithms. Where the human there is, that's guaranteed.
What's the parameter for attractiveness?
It's a score from 0.
Parameters means like their facial features or?
Oh yeah, so you bring up an interesting point. So you have human engineered features versus AI, and this is also a reason why humans are starting to lose for some of these head-to-head comparisons. So plastic surgeons have come up with 60 parameters during the last century of facial symmetry. They've got all these measurements. They can actually tell you why this individual is attractive or not. The nice thing with deep learning is you're not limited to that. So before, with classical feature engineering, if any of you have done that, it's very labor intensive. I did a lot of it with audio. It takes a long time to get features out, get them tested. You're typically dealing with tens, hundreds. It's very rare that you can break into the 1,000 class for manually engineered human features. Deep learning, these models are trained on 10 million, 100 million parameters. So deep learning can go past that. So, and I think that's a key difference that I see. With deep learning, you kind of handed the feature engineering over to the deep net, where before, you had a very strong say into why things matter.
Do you change the weightage of the features, like by human intervention, to tweak the model so that it's more accurate? Like you said, you remove racial bias. So
oh yeah, we didn't do anything to improve accuracy. We improved the targets to make them more reasonable with scaling. Something I did show in this slide is one of the cool things with deep learning is you can do spatial activations. So we actually have a picture of Keira Knightley. So our attractiveness net thinks Keira Knightley and Zac Efron are attractive. I don't disagree. And we have a heat map that shows the face, where you can actually see what regions of the face it's activating on. And the interesting thing is the regions of the face are common plastic surgery modification points. So bottom of the nose, lips, eyes, and it's different for men. So it's kind of fascinating. There's a really strong storytelling element. A lot of times deep learning gets a bad rap for being black box, but with GradCam, with topic discovery, like the country map that we showed you, that came from a net that was previously trained in country. So there's some really powerful storytelling that comes out of these deep learning models. And so that's kind of our active research. We do a lot in the storytelling side.
So, quick question, talking about celebrities and models and attractiveness, could there be in our future one day where an entire movie is made with GANs for actors, replacing actual actors, which costs $10 to $20 million a film?
Yeah, I think we're actually much closer than people realize. What you could do sooner is you can have an actor and actress that does all the acting, but they're not super attractive. And then you can actually just superimpose the target that you want for each movie. So depending on the region that you're selling to, you could say, well, these actors will definitely appeal to this audience. with the GANs where you make fake images, there's also GANs where they make fake video sequences. And no one's really brought the latest technology. It seems like video lags a few years behind image improvements. So image improvements happen, and then a few years later, the video side, for whatever reason, it shows up in a white paper. So I think you're definitely going to see some pretty freaky video GANs in the next 2 to 5 years. So that, what was the name of that movie? There's a movie where there's an AI celebrity.
Ex Machina.
That's Final Fantasy did that, I think.
It is this woman, she had blonde hair, she was really famous, she didn't exist. She was in all these movies, she was just 3D composed. So she was animated after the fact, and so the whole movie is about them trying to avoid getting caught that she doesn't exist. So that scenario is, it's a pretty good movie. So that scenario is, something you could definitely see maybe in the next 10, 20 years, maybe sooner. We keep getting surprised by AI.
Do you have any of the examples that you talked about available that are set up for MXNet that we can download and try out?
So we don't. So we don't have a public Git repo right now with some of the MXNet. Maybe if you reach out to me directly online about what you're trying to do, because Amazon also has some really good resources too around MXNet. If you're trying to do video specific, I can make sure you've got some of those elements.
I'd just like to see a video example on the MXNet website or in the repo directly.
Oh, okay.
That's,
Yeah. Yeah.
I'll talk to you. We can let's make that happen.
Send me a message on LinkedIn. We'll make sure that you get what you need. Okay. And by the way, Ben Taylor Data on LinkedIn, Twitter. I'm pretty active on my phone, so if you're trying to get a hold of me, and if I don't respond, just follow up. So, okay. Thanks, guys.
Thank you very much.